You couldn't have missed all of the excitement surrounding the James Webb Space Telescope and its new discoveries. It outperforms all other space telescopes, including Hubble. It's so large that it had to be folded up like origami to fit onto the rocket that took it into space. Because it is so precise and sensitive, it must be kept at temperatures no higher than absolute zero to prevent internal heat radiation from interfering with its sensors. It was so expensive to make that it cost $10 billion, and it was so complicated that it took decades to complete. There were 300 potential failure points between it and proper functionality. But it's finally here, and it has an incredible mission to search for evidence of life in planetary systems, to understand the formation of planets, stars and galaxies, and to peer out across the universe to objects so far away that the light they emitted has been traveling for nearly as long as the universe is thought to have existed. In other words, the James Webb Space Telescope was designed to detect the first stars and galaxies at the edge of our known universe, objects dating back to the beginning of time. And the first images have begun to arrive. In this episode, we look at some of the early photographs from James Webb. For more amazing discoveries in space and from the James Webb Space Telescope, subscribe to the Space News YouTube channel and hit the notification bell to not miss those amazing videos. The James Webb Space Telescope was conceived in the 1990s with the goal of costing less than $1 billion and launching in 2007. However, numerous setbacks and delays plagued the project, repeatedly pushing it back. It did not officially launch until December 2021, and it has spent the intervening months slowly unpacking itself, powering up its systems and testing its hardware. It's a 6,500 kilogram beast with a sun shield 14 by 21 meters in size, roughly the size of a tennis court. Its light capture mirror is 6 times larger in area than Hubble's lens, allowing it to pick up more photons from further away and produce crisp images. It has a plethora of cameras and scientific instruments that enable it to see across the infrared spectrum. This is an important feature for its distinct mission. Because of the expansion of the universe, all light from the furthest reaches of space has been stretched to the point where, no matter what it was to begin with, it is now all at least infrared light. As a result, the only way to see these light sources is through an infrared telescope. Furthermore, infrared is better at cutting through dust clouds and other obscuring debris, giving the James Webb Telescope the incredible ability to see objects that Hubble cannot. This telescope is frequently compared to Hubble, as the James Webb Space Telescope was originally intended to be Hubble's successor. However, given their slightly different fields of view, Hubble sees mostly invisible light spectrums, whereas the James Webb Space Telescope sees almost entirely in infrared and can't see some visible light spectrums at all. It's more accurate to say that the two telescopes complement rather than compete. They form a powerful duo that expands our understanding of the universe. But that's not why you've come. You've come to see what James Webb is capable of. Let us begin with our galaxy and gradually expand our vision outwards to the edge of the knowable universe. You're here for some amazing discoveries. What James Webb discovery are you most excited about? Let us know in the YouTube comment section below. The Cosmic Cliffs are our first destination on our journey. The Cosmic Cliffs, also known as NGC 3324, are located about 7,600 light-years away in the Tarantula Nebula. These are massive structures that are around 7 light-years high, and what you see here is only a portion of the nebula as a whole. The actual nebula is much larger and has a hollowed-out center where stellar winds have blasted all nearby dust away from stars. The edge of this hollowed-out bubble is what we're looking at here. Scientists are fascinated by this region of space for one simple reason. It provides answers to questions about the formation of stars. Dust and matter congregate in this zone due to stellar winds, forming a birthing place for stars. Despite our best efforts, there are many mysteries surrounding this process. How did they come to be? What do the various stages look like? It is difficult to say. The dust, which is both necessary for the process and a major impediment to seeing it happen, contributes to the difficulty in finding answers. It wraps around the forming stars like a protective cocoon, preventing scientists from seeing what's going on at critical moments. James Webb corrects this. Not only does this image contain more detail than Hubble's, but we can also see what lies beneath the layers of dust thanks to James Webb Space Telescope's onboard MIRI, or mid-infrared instrument. Look how much clearer the image has become. This will continue to provide scientists with data on star formation for a long time. Isn't this fascinating? Please share this video to show everybody how fascinating our universe really is. The James Webb Space Telescope learns more about the end of their life at our next stop, And for this, let's take a closer look at NGC 3132, also known as the Seventh Ring Nebula. The image on the left was captured by James Webb Space Telescope near infrared camera, while the image on the right was captured by MIRI again. This is a planetary nebula, though the term is a little misleading. While regular nebula gives birth to stars, planetary nebulas do not give birth to planets. Instead, it was an unhelpful naming convention used by early astronomers who noticed the nebula's round shapes and thought they looked like planets. Even though our interpretation of the name has changed, the name has stuck. Planetary nebulae like this one form when dust and cloud are ejected from dying stars near the end of their lives. Knowing the chemical composition of this dust is important because knowing what materials exist in the universe helps us to understand what later waves of stars might be made of. So, once again, James Webb's ability to peel back the layers of dust to reveal what lies beneath is priceless. Compare this to Hubble's image to see the increased detail James Webb Space Telescope can provide. Check the YouTube description right below this video for some amazing facts. Scientists have learned from this that the second star in this system has yet to explode, implying that the formation of its planetary nebula is still possible. We can also get a better sense of how the two stars' gravitational interactions stir the nebula, mixing the dust in fascinating patterns. Let's take a look a little further out, beyond our galaxy. It makes sense to find a location like this if we want to see star formation. The Tarantula Nebula is 161,000 light-years away from us, so named because it resembles a giant tarantula lurking within its silken web. Aside from its obvious otherworldly beauty, scientists are drawn to this area because of its resemblance to the cosmic noon period in the history of the universe. Star formation was at its most prolific around 1 billion years after the universe began, according to our best understanding. It is assumed that conditions would have been similar to this. James Webb has been able to spot stars that are just forming here, a fascinating time period to study. Let's take another look. As our vision expands, we lose sight of individual stars and begin to see things on a galactic scale. Beautiful dances are being performed even here. Stephans Quintet is a grouping of 5 galaxies, made famous by the film It's a Wonderful Life. It is predicted that 4 of these galaxies will collide one day. 2 of them are already doing so. The brilliantly hot dust being kicked off as these 2 central galaxies circle each other is visible thanks to James Webb. The gravitational forces are mind-bogglingly strong here. The energy is palpable. It's a dance that can only be appreciated at these scales. This image was created by combining nearly 1,000 separate images taken by James Webb and then assembled by scientists, giving it an incredible resolution for picking out details. Let's zoom out once more, until even James Webb is straining to see in Webb's first deep field. This image was captured from a location so small that a single grain of sand held out at arm's length would obscure it from view in the night sky. Individual stars are almost completely absent at this scale. The majority of what you see here are galaxies, not stars, which would be too small to detect on their own. Here, gravitational warping creates fish lens effects by bending light around closer objects, distorting what lies beyond. We can now see the outskirts of the universe. This is one of the oldest galaxies we've ever seen. It is so far away that the light from its birth at the beginning of the universe has only recently reached us. What is its location? We'll need to enlarge the image. Do you see what I mean? It is, after all, quite small. By comparing the light emitted by this tiny red galaxy to normal visible light from similar sources, scientists can determine how far it has redshifted and thus how long the light from it has been traveling. This minuscule dot was discovered to be 13.1 billion light-years away. Given that the universe is thought to be 13.7 billion years old, this is one of the earliest galaxies we will ever be able to see as far as we know. You may be disappointed by how small it is now. However, there is some cause for optimism. Compare this image to one taken by Hubble of the same area. James Webb Space Telescope's image is obviously crisper and clearer, providing more detail and displaying more objects. But there is one more significant difference between these 2 images. Hubble captured this image by staring at this patch of sky for 10 days, slowly collecting every photon it could from this region of space and compiling them into a single image. James Webb Space Telescope, on the other hand, only needed half a day to capture its image. This means that if James Webb Space Telescope could capture such a detailed image in 1/20th of the time, imagine how detailed an image it could capture in a comparable amount of time. In other words, this tiny little dot is most likely not the best the James Webb Space Telescope has to offer. I hope these images have given you a sense of both the scientific breakthroughs possible with the James Webb Space Telescope and the beauty of the universe. Images like these take my breath away. Unfortunately, we will have to wait to see what other discoveries the James Webb Space Telescope has in store for us. So, stay tuned for more videos about the James Webb Telescope's latest discoveries. Don't forget to subscribe to our YouTube channel and hit the notification bell for more amazing discoveries. We would highly appreciate it if you can share this video to show everybody how amazing our universe is. Thanks for watching, see you in the next video, take care, goodbye.